All right, as I said, welcome. This is, I think it's our 11th one of these in a series of little webinars we've been putting on the website, trying to cover a lot of things in the control that sometimes we don't get to discuss with people. So this is going to be over program parameters and some user preferences. So we'll go ahead and get started here. I'm going to go into the program parameters, which is off of the input screen. So input program parameters. And there are different groups based on tabs. You'll see across the top of the screen, we've got general 1, 2, milling, holes, so forth. You may or may not have all of these. It depends on what your machine configuration is and what options you have. For example, you won't have a probing tab if you don't have probing on the machine, and you won't see some of the things we talk about for automatic safe recovery or this rotary axis configuration if you don't have a rotary machine. I also want to point out that you might see a few differences in the way things are labeled, depending on the software version that you have and how old that software version is. But pretty much all of the older versions have everything we're going to discuss today. Or a lot of what we discuss today will be in those older versions, but there may be one or two things that you don't currently have on your machine. We'll go ahead and get started here with the General 1 tab. Number 1 is the Retract Clearance. This is an incremental distance above the Z start for every block. It's a transition move that we move to before every block of the program. So if we're transitioning between a mill circle and a mill frame or between holes and so forth, we're going to retract to this incremental distance above the Z start. So if you have a Z start of negative value, let's say we're doing a Z start of -1 inch, and you have this retract clearance to 1 inch, just realize you're going to then only retract up to what would in essence be Z0. So this is an incremental distance above the Z start for every block. So keep that in mind. Most people set this to 1 inch. It's probably the most common that I see. Sometimes newer users will put it to 2. But that's basically what it is. This next one is to turn on or off, be able to enable or disable secondary retract clearance. So this defaults to off, but if I were to put this on, then it highlights this next field down here, which is a pecking retract clearance. When we're pecking between levels in a pocket or in holes and so forth, we're automatically going to retract out to the Z start. Well, sometimes you may need to retract to a different location. Think of this as the R plane and the initial plane in G-code drilling. So we're able to then put in another value here, which will be an incremental distance from the Z start. So you may have an instance where you would want to turn that on or off. I see it used once in a while, but not real often, but that's where we do it. We go here, enable it, and then you can put the value in. The next one is rapid traverse of the machine. This is the maximum. It's able to be set to whatever the maximum is for your particular machine. If you have a VM series machine, this will be a little bit smaller number. If you have a VMX, it could be a larger number. This will either be in inches per minute or millimeters per minute, depending on what your control happens to be set to at the time you go in here. But this is how fast you will allow the machine to rapid when you put the potentiometer for rapid override to 100%. I also like to point out that override knob, 0 to 100%, is going to be a percentage of whatever this parameter is. So if you are new to the machine or you have a newer operator and you want to back this down for some reason, then if you put 400 inches a minute, for example, then that override knob will be a percentage of this setting. Every new program will have these default settings. I should have mentioned that in the beginning. So whenever I start a new conversational program, you're going to get a group of default program parameters that will save with the program. If you find that you're making changes quite often, let's say that you always want this to be a smaller number, or you want to put a value into your retract clearance and you want that to be there all the time, then once you've made those changes, you can look at the soft keys here on the right side of the screen. You have save as user default. If I click this, then whatever my parameters are at that time, all of them will become the new default. So I won't have to go in and change these all the time if it's something that I use often. And this is one that you may do that. You don't ever want the machine to be able to wrap it at that. The next is the Pec Clearance Plane. Well, we're pecking, let's say we're pecking to 100 thousandths deep pecs between, we're doing a pocket and we plunge down 100 thousandths and we peck, and then we plunge down to the next 100 thousandths and we peck. When we're finished with that particular peck of the pocket, we're going to wrap it up to our Z start or to our retract clearance plane that we've set if we choose to do a second one. And then we're going to wrap it back down to within whatever this parameter is set to begin feeding. So in my example, if I had 100 thousandths deep peck on the first cut, I would wrap it up, wrap it back down to -50, and then it would feed down to that next peck move from 100 or 50 thousandths above the last peck. So this is usually a pretty good setting, but some people do change this from time to time. The chord error is another one that sometimes people don't really understand. So I got a little graphic here. Whenever we program a circle conversationally or an arc, it's never an actual true arc. It always is a faceted bunch of lines that the control is going to create. And the chord error is going to be the tolerance, if you will, between what the round circle would be and what the flats are. So between those errors is what we call the chord error. Now you'll notice that that was a pretty small number. It's 98 millionths, so it's less than 1/10 anyway. Resolution of the machine is 1/10, so there really is never any reason to make this any tighter. There are instances, at least in the older days and the older controls, people would make this a larger number for some of their roughing. That way it would run a little faster, and then start to tighten it up for their finish passes. But for the most part, in the new WinMax controls, you really never will have a need to change that. But that's what the error or what the chord error is. The last one on this tab is the override lockout. If I want to lock out the spindle speed, the feed rate, and the rapid, so those knobs, the overrides are locked at 100%, then I can just go in and set that to 100. Now those knobs can't be adjusted on the control. If I do need to, I can come back in here and turn those back off, or that lockout off, and now I have access to those potentiometers again, and I can adjust my rapids and so forth. This last one here, if you have a rotary machine, it's going to tell you whether one of the other parameters is set to ISO standard or non-ISO, which just determines when you move positive or negative of that rotary axis, whether it moves in the standard direction that most machines do, or if it is set up to do the opposite. So this can't be changed, but it is giving you some information here. The next one we'll go to is the General 2 tab. The very first one, again, is from the old days. This is the depletion retract. In older controls where we had memory issues, if we were trying to feed a program in through DNC or something where we were streaming that program into the control, at some point the buffer would become full. It would run everything, but then it would become starved for information. While it was buffering more information, the control would automatically lift the tool off of the part by this amount, so we didn't sit there and dwell and gouge the part. Once we filled the buffer again, it would drop back down to its location where it's supposed to be, and it would take off again. With the memory we have in these controls today, this is not something that we see, so it's really not used. A lot of the reason you're going to see some of these older parameters that aren't being used still here is because people have these machines. If I create a program from a newer control and I save it out to one of the older, to be used in one of the older controls, these parameters need to be there. So that's why they're still here. But again, this is one that probably doesn't get used ever anymore. The next is interrupt Z, cycle Z retract. So if I have this set to yes, when I hit the interrupt cycle button on the control panel, the little yellow button, the Z axis is going to retract before the control enters the interrupt cycle. And that's what I want most of the time. However, if I have a woodruff cutter or a key seat cutter that's cutting something in the side of a part, or I'm doing some kind of undercut, I don't want that to be able to happen. So I set this to no. That way, when I hit interrupt on while this is active, then the Z will not automatically go up. I have the option then to hand wheel away, move the Z up, and when I go to recover, it's going to ask me whether the Z can plunge or not, and there'll be some things on the screen that will walk me through what to do in that case. So depending on what it is that you're doing, you may or may not want that Z to automatically retract when you interrupt. And the first Pec offset, this is a useful parameter, but it's also a little misunderstood, and you have to make sure that you're using the same Z start for every block while this is active. So what this does is when I have a Z start of 0.1, for example, that's a very common Z start that we see people use. The tool is going to rapid to that 0.1 above the part, and then it's going to begin pecking from there. So let's say I'm using a 4-flute, carbide end mill, and some steel, and I'm only pecking at 25 or 30 thousandths. Well, if I rapid to 0.1 above, I'm going to begin to peck from there. So I might get 2, 3, or even 4 passes of air before I ever get into the part. So one of the options would be to reduce that Z start so I'm closer to the part, and that's what we see a lot of people do. Or I can simply put in a 0.1 here, and it would rapid to the 0.1 above. It would drop down, then feed down from whatever this parameter is set to from my Z start and begin pecking at that point. So it offsets my first peck to eliminate me cutting that air. So again, if you're going to use this, it is a very helpful one, but you need to make sure that all your Z starts are the same. For example, if I had a 0.02, 20 thousandths above on a couple of them and 0.1 on others, and I put 0.1, well, my first peck is going to begin 80 thousandths into the part on that one. So something to be aware of, but it is a useful parameter if you use the same numbers often. The next one here is move to a safe position during tool change. If I select this to a yes, then whenever the machine is sent home and going to do a tool change, the table X and Y will return to the calibration point. Tool change will be executed, the table will come back. Now, it's worth noting that in these program parameters, this is only for automatic operation. Under the machine parameters, which we'll see when we get into the user preferences screen later, there is a place you can set this for manual tool changes as well. So you can have that one turned off and set this one to a yes, and it will still do this, or vice versa. So those two are independently controlled. Manual tool changes and auto tool changes controlled in 2 different places. This is only for automatic tool changes during auto operation in a program. So hopefully that made sense. The next, tool change optimization, yes or no. If you have tool change optimization on your control now and you've been using those, that's a block that we insert into the program to tell the control where to begin optimizing my tool changes and where to stop. I can, under some circumstances, for example, if I do a recovery restart, a lot of times I can't be using my tool change optimization during that. So this is one place I could come in here, turn this to no. Basically, that is turning that off. I can do whatever I need to do. And then when I go back to normal operation, I can turn that back on. So this is basically an on and off switch for whether the tool changes are optimized in the program when those blocks are used or not. So this is just another one place you can go to turn those off. Keeps us from deleting them in the program or making changes. This last section down here has to do with the 5-axis machines. Not everybody has this, but I will touch on it here. We have when we're retracting the tool, we have 2 different things that we talk about. We have the vector retract and the Z limit retract, or the Z limit, or the Z retract. So let's think of a trunnion machine where I have the Z axis is stationary, the tool never tilts. In that instance, both of these are going to be the same. But on a machine where we have a tilting head, let's say we have the head tilted at 30 degrees, I now have a vector retract, which is along the angle of the tool, that the tool is going to retract out until it hits a limit of machine travel. In my example, on a swivel head, that would be the X, we'd run out of travel. And then the Z is going to go up, where the whole head will move up to the home position. We do this between every time we sense a transform plane change in the program, we automatically do that. We'll retract all the way out to limit, and we go all the way home in Z. Well, sometimes people want to be able to control that and not retract as far. So you can simply turn these on, and then that gives you two fields here where you can adjust how far away that retracts before the Z moves and whether the Z goes all the way home or not. So there's a lot of rules with this. We'll always still retract to the farthest point away from the tooltip, the previous position, and for the preparing for the next position. But you do have some control here, and if you have a 5-axis machine and you want to give that a try, you can play with those. So just realize that one of them is along the angle of the tool, the other is the Z, or the entire head moving up. Linearize the rotary moves. I'm not going to talk about that one. That's a really, really specific thing that probably no one will ever get into, and it really gets too deep for this type of discussion. Just know that you're probably never going to change that. All right, the next one here is going to be the milling one. Probably the most two common parameters on this one that we change is the blend offset and the blend overlap. If I bring up the thought I had a program or a thing for that. But basically, we're going to start away from the part. We have a blend overlap, or I'm sorry, we have an automatic blend on and off when we do conversational programming. Let's say I'm staying to the outside of the part. The blend offset is how far away from the programmed path will I start when I blend on. The blend overlap is when I go full circle around my circle. In my example, I'm going to go past the tangent point where I blended on whatever the overlap amount is, and then blend off automatically. So that gives me control over if I'm leaving a little mark when I've blended on. If I go past it when I blend off, I can get rid of that. Sometimes I'll make this number much smaller if I'm using a larger end mill and a smaller hole. I can't blend off by 3 millimeters or this 118 thousandths. I may need to take this down to 1 or 2 or 3 thousandths or something like that. So these are ones that get changed pretty often, but that's what they control. Now the finish feed and finish speed, these both parameters are only for Ultimax users. If we look at a block now for WinMax, we have a tab for roughing and one for finishing, and we have speeds and feeds that we can put for each one of those tools independently. In Ultimax, we didn't have that. So this would be a percentage of the roughing feeds and speeds that is being used for finishing. So I would either do 100%, smaller, 120%, whatever that is. This is how we controlled it. So if you have a WinMax machine, these won't be used. If you have an Ultimax machine, you probably are already aware of that, but that's what these are. The next one talks a little bit about the differences between WinMax and Ultimax as well. So if you did use a finishing tool in Ultimax, or if you're using the default setting in WinMax, this is where you control how much you're leaving for your finish in X and Y and in Z. These are global parameters and they work for every block. Well, you may have noticed in the programming blocks, there is another tab called Allowances. And if you haven't been shown this yet, it defaults to off. Those would be grayed out. This is where we can turn that on. What that does, if I change this from program parameters, which means I'm using these two fields here in the program parameters, to data blocks, these two fields are now ignored. And if I go to the machining block, I see I now have an allowances tab where I have finish X and Y and Z, and this is only for this block. So this got us away from the global setting for everything, because there are times when I need to leave more or less because of chatter or whatever the case may be, and those global parameters were a little bit problematic. I had to insert change parameters blocks and things like that. So here, by turning that to data blocks, I've now opened this allowances tab, and I can control these values for this block only. The other thing to note here is if I do put a value here, let's say I put 20,000 or 30 thousandths here, and I don't use a finishing tool, then it will not remove this 30 thousandths. So what that allows me to do is maybe stress relieve a part. I'm going to leave material for grind. I want to right now remove most of the material, leaving some, and then later on I can come back in, copy and paste this block again, and remove those allowances back to 0, so it'll cut on size. But this gives me the ability then to leave stock without having to lie to the diameter of the tool or the geometry of my program. So those are, that's a very helpful thing, and very happy to see that when it came out in WinMax. So if you've seen this tab and it's grayed out, again, where we turn that on is in program parameters, milling 2 or milling 1, and it's the stock allowance mode. Set that to data blocks, and that will enable that particular field. Milling direction, we always want to climb mill when we can, especially on finish passes, and whenever we're doing a mill circle, mill frame, a contour, whatever, we automatically default to climb milling on that final pass. If for whatever reason, because of tool pressure, pulling up the part, whatever, you need to change that, you can simply put it to conventional, and then from that, while those parameters are active, then you will conventional mill those final passes. So it gives you a little bit of flexibility there. Pretty special cases when you would do that though. When I'm pocketing, the default step over percent is going to be 50% of the tool. If I want to change that, I can set it here, but I can also change that in my pocketing routine in the block itself. So this is just the default, what automatically gets put in that field in the program. So, but I can change that here if I wanted. Again, change that to 25% if I choose, and then save that as my default. So going forward, all blocks or all pocketing routines would have that 25% or whatever I change it to. The next one is an insert arc or insert line. Got a couple of little graphics here to show that. Insert arc, which is what we default to. If we're coming up one side of this feature here, we're going to go back down this side. How do we transition from this left side to the right side? We're either going to roll around here or at an arc, which is going to give me a D-bird, not exactly perfect point here, sharp point, but it's going to be what 99% of the time we want. But there are times when you want that to be perfectly sharp, and we don't want to roll that, and that's when you can say insert line, and then it will move in a straight linear move from left side to right side and then come back down. Both of them give us a point here. One is just sharper than the other. So that's what that parameter does. It gives me the ability to make that change if I need to. Milling 2, if you don't have ulti-pocket with helical plunge entry turned on in your control, this milling 2 will not be selectable. It'll be grayed out. If you do have it, then you are able to then, for roughing tools and finishing tools, determine whether this is a helix or a straight plunge. And if it is a helix, what is your slope degree? We default to 10, which is really, really high. You're going to always change that. And then the radius of that helix is going to be a percentage of the tool diameter, and it defaults to 25%. So if this is something that you're doing often, a lot of times the tooling company that you purchase your tools from, if this tool is able to plunge like that, then they'll give you the types of information that you need to put in here. If not, 25% works really well, and you're always going to want to go between 2 and 3%. on your slope degree. Anything more than that, you can crowd it and have some problems. So anyway, you can set those independently for the roughing tool and the finishing tool. Now, operator specify pocket start point. If I set that to yes, first of all, I'm going to show you this contour block here. It's a pocket, it's a lines and arcs pocket, and I don't have any place to put in a pocket start point. I'm pocketing inward. If I go to the program parameter there, milling 2, I set this to yes, and it tells you that it's only, oh no, I set the wrong one. Select yes to enable the operator specified pocket start when inward pocketing. If that's set to outward, these new fields won't appear, but if I'm set to inward here, then I have an X and Y position where I can actually tell the control, I want you to plunge here, and that's where the pocket will begin from. So I can drill a hole there, for example, and then tell this where to go plunge. So I'm plunging in that hole if it's really hard material or whatever. So that's what that does. That gives me 2 new fields within the block to put that value in. Pocket plunge near center. This just means that the control on irregular shapes is going to always try to plunge near the center of the pocket when it can. In mill circles, mill frames, ellipses, it automatically does that. So we don't have to worry about it there. This is just for when you're doing a lines and arcs pocket, you may want to try to force it to plunge in the center. It may be trying to plunge somewhere at 3 o'clock or 9 o'clock on the part or something like that, and you want to try to force it to center. You can set that right here. Also, if I set the operator specified start point, it allows me then to plunge outside of the pocket. So let's say that I had a U-shaped pocket where one side was open. I still have to program it as a closed pocket, meaning that, for example, if I have a long rectangle, I still have to start and end at the same point, but because I can't do a pocket if it's open. But this, if I know that that part is hanging off the part, for example, so part of that rectangle cuts into the part, but the left edge of it is actually out in air, and I want to plunge outside of that and come in through that open wall, then I set this allow plunge outside pocket to yes. That allows me to put that start point that we saw in the program block a minute ago, that XY, can then be outside of the programmed circle, program frame, whatever it is, and then come into it from there. So not something that we do often, but it is something that could be useful. And we often, as conversational programmers, will create a pocket that might hang off the edge of a part because I have to get that feature. It's not a closed pocket, but I have to do that often. So this is one more trick that we could do when we're doing that. You can play with that if you think that would be helpful. This next one has to do with adaptive path, which is the high-speed pocketing routines. On any of the newer controls, it's automatically there. You'll see adaptive path zigzag in one way when we set the pocketing type. You'll have inward, outward, and then these 2 adaptive paths. This number is something that you probably won't ever change, but it is a linking parameter. So it's setting a tolerance for linking, and it uses this number as a multiplier of the tool diameter. It's difficult to explain. Most people never change it. If they do, they change it to a 1. So if whatever you're getting in your adaptive path pocket is something that is not what you're expecting, it's taking too long, it's lifting the tool too much, those kind of things, change it to a 1, and that should take care of it. Those are the 2 most common settings, 5 and 1. 5 is the default. So that's what that is. Has to do with the adaptive path pocketing. The next one here is the holes. So this will handle drilling, tapping, and boring. Bore orient retract. So if we are using a single flute or a single pointed boring head, like you would see on a Bridgeport or something where you have one point, and that's going to be your cutting point. When we bore to the bottom of this hole that we're going to, or this hole that we're boring, in doing a boring cycle, a specific boring cycle in the control, we're going to orient the head. We're going to then move towards the center of the hole by this value, in essence, pulling the tip of that cutter off of the wall by this amount, and then wrap it up out of the hole. So we don't want to drag that tooltip up that freshly bored surface if we can help it. So that's what this allows us to do. It'll orient the spindle, it'll move towards the center of the hole by this much, and then go up. Here's some dwell in seconds, so I can set some dwelling times at the bottom of a drilled hole or a bored hole. So I can clean that out a little bit if I've got, especially if I'm running a slower RPM. When I get to the bottom, I may want to run a couple of revolutions there, so I'll just put in a time. And then you have the retract percentage of up to 10 times the speed you went in that you can retract that tool out. So we can set anywhere from 100 to 1,000. That's either 100% or 1 time or 10 times the speed that it went in. And then the next one has again to do with the interrupt cycle, whether I want that interrupt cycle to be able to be activated during a bore or reaming cycle. And it defaults to a yes. Usually you do want that, but sometimes you'll want to restrict that, so you can just simply set this to a no. I'm going to go to the performance parameter next because that's something that everybody has, and then we'll go talk about the probing. So performance has to do with the surface finish quality for roughing and finishing tools and their default value. Inside the block, for example, you'll have an SFQ that I can adjust here as well. Again, those are just the default values that are in that performance tab. So if you're not familiar with these numbers or what they actually are, we've got from number 1 to 100. 1 being the slowest but most obedient tool path. It's also going to take the longest to cut. And you have 100, which is the fastest, but it'll cut quicker, but may or may not have some less than desirable surface finish. So we found that 80% for roughing and 20% for finishing works really well. And most customers use roughing tools just to rough and finish their part. They don't always use a finish tool. So 50 to 80 seems to work really well. If you need to tighten those things up, then taking that down to 10 or 20 for a finishing tool, also very common. Just know that that's going to take a lot longer to run. So that's where we can control those here. And then we have a smoothing tolerance. The smoothing tolerance is more for a G-code program, but let's say that we had an arc that was made up of a bunch of lines. It's not a G2 or not a G3 arc that's in our program. It's actual G1s, point-to-point lines. And I can set a tolerance here. Let's say I put in 5/10. The control, if it can vary from the tool path no more than 5/10,000ths of an inch and catch more of those lines, those points, and make that one smooth arc, it'll do that. So if it can look through a window of that tolerance, if you will, and see 3 or 4 or 5 of those points within there, then it will go from the first point to the last point in a smooth arcing motion, in essence smoothing the motion of the machine. So I'm going to get a better surface finish, I'm going to get smoother movement, shorter cycle times. It'll just be a all-around better process. So that's what the smoothing tolerance does. It can also be set in the program using the G5.2, and this Q value then would be your your value. And the last one here in the probing or the program parameters is the probing. So if you have probing, you'll have this here, and it is tool probing. I can set to probe the incoming tool automatically for every tool change, the outgoing tool after every tool change, or both. So if I'm checking for tool breakage, or I'm going to set it to outgoing. I want to make sure that tool was still there when everything was done. If I'm going to be setting some kind of tolerance for my length or my diameter, I probably want to check that when it's coming in, because then it will automatically probe the tool for whatever process you have told it to do in your tool setup. So if that tool is set up to program length and diameter, then whenever it does a tool change, it's going to go ahead and probe that tool for both length and diameter. Then it's going to look at these values that you've set for the tolerance. If it changes more than whatever you have set here, it'll stop the process and flag that control or flag that tool as defective. So that's what these are. I can set whether I want it to go in or coming in or going out, off, both, whatever. Set a tolerance for that. And then if I am using it, then I can set the where it'll either change the diameter of the tool or the diameter wear field, rather than always changing the diameter field, if you will. This section here has to do with probing the part setup. This one, to retain or not retain, really just means if I've done a setup and I'm doing a probing cycle within my automatic program, so inside my conversational program, I'm doing some setup probing, do I want it to automatically and permanently change the numbers in my part setup to the new numbers it just found? Or do I want it to just be active while we're in auto mode? As soon as I hit reset or the cycle is done, the numbers it just probed have been lost and the original part setup stayed unchanged. So basically that's what it is. Do not retain or retain all values. I typically have it retain all values. That way if I stop the process while that part is active, I don't have to reprobe it. Those new values have physically been changed in the part setup, and then it will stay active until something changes those again. The start coordinate preference, when we're inside of probing routines or inspection routines, it asks you for an X, Y, and a Z position for the probe to automatically go there. I can set those values in the program as either machine 0 or part 0. So if I've already touched the part off and I'm retaining those values, then I can usually be close enough to use part 0 and those numbers make more sense in the programming. If I leave it at machine 0, then those are literally from those locations are from home. Let me I'll put a cycle in here real quick to show you that. So I'm going to insert a miscellaneous probe part setup, for example. And these are the values that we're talking about. If I was probing my part setup manually or in my setting up the job, I would hand wheel that probe into position. Well, here it needs to reference an X, Y, and Z location to take the tip of that probe to these positions before it begins to probe the edge or the circle or whatever it is you pick. So these values are either going to be machine position or part relative. And that's what that parameter setting is asking us there. And then do you want the inspection results to be shown on the screen after it's done? So that would be used during an inspection cycle in the program where you're inspecting something that has been cut and you're just wanting to verify its size or whatever. It'll pop those up and display on the screen. So those are the program parameters. Hopefully that helped. Most of them are pretty self-explanatory. A few of them are very specific cases, but pretty much everybody kind of understands what those are. So let's go into the user preferences. So if I were to hit the auxiliary button on the control, select the little utility knife or utility screens button. Then it's going to bring up this set of menus. And the user preferences is one that we see people go into a lot, try to change some things, and they may or may not understand what those are. So I want to go through those a little bit. First are the user interface settings. These are ones that the size of the fonts, the menu positions, those are ones that we ask you probably don't change those because they can cause some really odd behavior, list the icon sizes and so forth. If those, we should probably leave unchanged because again, you'll get either part of your soft keys may disappear on the bottom of the screen because they're going to be off the screen, or everything will be too small to read. It may behave differently in some fields than others, so we recommend not changing those. This edit mode, however, is one Ultimax Classic or Windows Dialog. If you are someone who likes to hit Tab a lot on your keyboard, you might want to change this to Windows Dialog. It doesn't require the enter key on the control or on your keyboard. On the machine, it's usually not that big a deal because we have all the numerical keys, everything is on the keypad, and we're just used to hitting enter. On the desktop software, however, this happens a lot where they constantly tab when they're doing things outside of WinMax. So when they're in WinMax, they just automatically tab. So you might want to make that change here for that. Again, on the machine, probably not as important, probably not something you would change, but on the desktop software, definitely. Enable program restore. That means when I reboot the machine, it's going to load all the programs that were loaded when I shut down yesterday, for example. So I'll have my no names, the ones that I'd saved, whatever. As long as whatever is in there was saved within the last 2 minutes before I shut down, because that's our auto save. Every 2 minutes, we auto save whatever's in that program manager. Then when I reboot, it's going to try to populate all of those. And that's what this will enable or disable. It defaults to yes. The next one that we hear a lot about is someone will say, hey, I got a program on my thumb drive, I put it in the machine and I can't find it, it won't show up. Well, that is usually because this defaults to no, showing all file types. It will default to looking only for HWM if you're in conversational, FNC if you're industry standard NC, or HNC if you're looking at Hurco basic NC, depending on what your settings are. Anything else will not show up. If it's a .txt or a .nc file, it won't appear. If you change this to yes, then it'll show you everything on that thumb drive. Some of them may or may not be able to be open. They may not be something that the control could take, but at least it will show every file type on there. So if you do have a .nc or a .txt or whatever, it'll show up and you'll be able to open it. Next one is the screensaver timeout. How many minutes do you want it to go before it times out and puts your screensaver up? Again, the icon size, don't change that one, leave that one to be. And this last one down here has to do with edit lockout. So I have a partial. If I set this to on, I have full and partial. If I set it to partial, and then I put these to yes for lock out the part or lock out the tool, then I can make changes to, let's see, what is it? Prevents changes to the program. So I can't make changes to the program if I am under the partial lockout without putting in a password. Here's your to change your lockout password. So anytime that I do any of this, by locking out the part setup, the tool setup, either partially or fully, then it's going to ask me for a password to make any of those changes. The password is all capitals, Hurco lockout, one word. That's the default. So if you wanted to change that to something else, you could do that by clicking here and changing that. Not a lot of people use it, but this is something that if you wanted to lock operators out of doing certain things, and they truly are an operator, they don't make any changes, then this might be something you want to do. But that's where you would do that. All right, so that's the user interface settings. Conversational settings, the math assist, that is going to be the way we alter numbers, meaning I would do a 0.1 plus enter, for example. If I want to alter a number, that's the way we've always done it. The standard calculator, I don't know how that behaves. I've never changed it to that. So kind of on your own on that one. I don't know what to expect. But Ultimax Classic, again, is the reverse Polish notation. We put the amount we want to adjust, plus or minus, and then the enter. Check Calc Assist for inconsistencies. I would leave that alone. That has to do with interpreting the program. It's going to look for Calc Assist. When you put in a few features or a few values and you leave a few blank, and then you go on to the next line, for example, and you put information, it will try to backfigure or calculate as much missing information as it can. And we want to leave this the default setting of no. Let's just make it simple. It works better if you leave it at no. The default conversational program type, this is what kind of conversational program are you creating? Universal is the new default. Whether it's a 3-axis program, 4-axis, or a 5-axis program, we leave it at default because there are new things like being able to use work offsets in conversational programs, G54 through 59, only available if you're using a universal program. The things like, I believe, the Allowances tab that we showed you in the program parameters, only active in a universal program. So if you're on a machine that has universal as an option, unless you are running something from an older machine, I would leave it at universal. It's just going to give you AdaptiPath, for example. Those kind of things, as they come out in the control, or if they'll be resident in universal, because that is the new one, that is our default, that's what we're going towards. We're really not putting anything new into the others. So, but this is where you would set what kind of program, the old standard 3-axis, rotary A, 5-axis, whatever. Universal is the best if you can do that. Now, to come full circle with that, when you do a universal program and I go to a 3-axis part setup, I'm going to have X, Y, Z, 4, and 5. Well, I don't have a 4th and 5th axis that show up on my 3-axis VM10, so I might want to turn those off. If I change this right here, display machine axis for universal type, to a yes, then my part setup no longer would say 4 and 5 here. It'll show what axes are on the machine, and if it's on a 3-axis, these two fields won't be there at all, completely gone. So that's probably for 3-axis users, something that people want to change. That's under the conversational settings, and it's this fourth one here. This one has to do with the data block. You want to prompt to automatically change the feeds and speeds if you're changing the tool number, or we'll just automatically do it by replacing them, prompting, don't replace, whatever. So this is how that behaves, and it defaults to prompting you and asking you, and you can say yes or no. This has to do with the new 3D import feature. If you don't have that new 3D import solid model import feature on the control, if you haven't purchased that, then this won't even appear. But this basically, do you want to put it in at the bottom of the program, or put it in wherever the cursor is, like the old DX? So that's what these are. Last one I'm going to go over here real quick is the NC settings. Again, what kind of NC program is this? Is it industry standard NC or the old Hurco basic NC? Universal, what kind of program is this? We want to make sure this matches whatever our conversational type is. So here we want universal as well. And then the rest of this is for your RS-232 setup, probably something no one uses anymore today. But if you did make changes, this is where you would do it. And obviously, there's going to be very specific, and you probably would work with service on getting what you needed for those. Disable the tool length offset table. This literally, we have this in one of the other webinars that we recently did, but basically I can set this to yes, and the tool length offset table for all of my NC programs will literally disappear. So if I never use G43H whatever in my program, or if I call those in my program, but I never go set those values, we will automatically default to the tool setup screen for our tool lengths. However, if there's any value whatsoever in that tool length offset table, we're going to try to use it. So that could cause a crash if you're not used to putting values in there and someone erroneously does that. So you can turn it off here and turn it back on if you ever needed it. And then things like saving the NC state file with the program, yes or no. Our diameter compensation, do we want to use only G41D with a value in the table? Or do I want to say yes? And if it's missing the D value, then it would use the diameter in the tool setup. Again, these are some things that are in one of the previous webinars that we did to cover all of these type of settings for our offsets, tool length, tool radius, and tool nose radius offsets. So you can go check that out if you want a little more information on those. And then basically, how are we going to handle any of our variables or macro stuff? Turn it on, and then you can monitor by settings and things here. Again, very specific things you might want to do there. And that, for those who are able to do that, or it makes sense, they're programmers, those settings right there will make sense anyway. So, well, we're coming up on our hour here. That took a lot longer than I thought. I thought it was fairly simple stuff, but those are things that we hear a lot of people ask about. So I wanted to cover those. I'm going to go ahead and open it up for questions now. I don't see anything typed into the comment section here. So I don't know if anyone still has a question. We'll give you a minute or two here to type something in. But if not, we're going to put this recording on the website. It'll be housed with all of the other webinars that we've done previously. And you will get, if you signed up, you'll get a link to that video as well. All right, well, I'm not seeing anybody put anything in there, so I'm going to go ahead and stop the recording.